In this video, we will perform the experiment to show that Malice's law holds for single photons using the Quantum Optics Educational Kit. The kit should be aligned to perform the GRA experiment, which means all three detectors are in place with a single beam splitter. Please confirm the BBO crystal is in the path and the pump laser is switched off. Place the 1-inch polarizer in front of detector T. Turn on the pump laser. Rotate the polarizer to minimize the count rate on detector T. Now, the polarizer transmission axis is perpendicular to the incident polarization. Loosen the screws on the front of the rotation mount. And set the dial to 0 degrees. Lock the screws in the faceplate. Place the polarizer between the beam splitter and detector B. The scale can face either toward the source or the detector. The scale just needs to be convenient to read, while the polarizer's face is parallel to the face of the beam splitter cube. Secure the polarizer with a clamping fork, screw, and washer. In the software, switch to the Malice tab. Choose a starting angle for your polarizer. For example, if 0 degrees is chosen, set the polarizer's rotation mount to 0 degrees and input 0 degrees into the angle field in the software. Click the Start Measurement button. After the measurement has finished, click the Add Point button to add the result to the graphs. Then, set the polarizer to the next angle, for example 10 degrees. Enter the same angle in the angle field. Start a measurement. And after it is finished, click Add Point to add the result to the graph. Repeat this procedure in equidistant angular steps until you have covered a complete 360-degree rotation of the polarizer. If an incorrect point is added to the graphs, click the Remove Last Point button and restart the measurement for the intended angle. After all of the measurements have been plotted, a sine-squared plot of the coincidence rate should be seen in the upper graph. In addition, the second-order correlation function, G2, remains significantly below 1 for the entire experiment in the lower graph. The combination of these two plots shows that single photons follow Malice's law. At the minima of the coincidence rate, the correlation function might spike higher than expected due to extremely low count rates, but the G2 value remains much less than 1, indicating single photon behavior.